All right, let's dive right into one of the biggest questions you can ask. What is everything really made of? I mean, deep down. We're going to go on a journey, from ideas thought up thousands of years ago, all the way to some of the most mind-blowing science happening today, to get to the bottom of it.
So let's kick things off with something that might, just completely mess with your head. Think about the chair you're in, or the device you're watching this on, or even your own hand. It all feels solid, right? But what if I told you that's basically an illusion? What if it's all just these tiny, tiny specks of stuff buzzing around in a huge empty void?
Okay, so to really get our heads around this idea of an empty reality, we've got to peel back the layers of matter. And believe me, every time scientists peeled back a layer, what they found underneath was way weirder than what they expected.
So way back in ancient Greece, they came up with this idea of atomos, the final uncuttable piece of stuff. And that idea stuck around for a long time. Fast forward to the 1800s, and a guy named Dalton imagines them as these solid little billiard balls. Then boom, 1904, J.J. Thomson discovers the electron, and suddenly the atom is this plum pudding thing. But the real game changer? 1911. Ernest Rutherford does this famous experiment where he shoots tiny particles at a super thin sheet of gold foil. He expected them to bounce back, but most of them just went straight through. He was stunned, and his only explanation was, wow, the atom must be almost entirely empty space with this tiny, dense little core.
And that huge discovery by Rutherford, it led us straight to the picture of the atom we all probably remember from high school science. So let's take a little trip inside and say hello to the familiar family of particles.
And here it is. You've got that dense little center, the nucleus, which is packed with positively charged protons and neutrons that have no charge at all. Then, whizzing around that nucleus, you have these clouds of tiny negatively charged electrons. And this basic setup, this is it. It's the blueprint for literally every element in the entire universe.
Okay, first up, the proton. The best way to think about the proton is like the atom's social security number. It's what gives the atom's identity. The number of protons tells you exactly what element you're looking at. You've got 1 proton, that's hydrogen. 6, you've got carbon. 79, hello, gold. It really is that straightforward.
All right, next to the proton, you've got its buddy, the neutron. It's neutral, no charge. And its main job is, it's pretty crucial. It's basically the peacemaker in the nucleus. See, all those protons are positively charged, so they desperately want to push each other away. The neutron helps the strong nuclear force keep everyone together. It's the glue holding the core of reality together.
And then there's the electron. This little guy is way out on the edge, orbiting the nucleus. But don't let its size fool you. The electron is the reason we have chemistry, at all. How these electrons are arranged, how they jump between atoms, how they share and bond, that's responsible for everything. It's why water is wet and why the cells in your body can do what they do.
So, okay, we've got our cast of characters, right? The proton, the neutron, and the electron. For a long, long time, scientists thought, this is it, we've found the bottom. But, physicists, they're never satisfied. They always have to ask, is this really the end of the line? Can we break these things open too? And the answer they found by smashing particles into each other at incredible speeds was a huge, resounding no. Not even close. We were just getting started.
All right, this is where things get really wild. We're about to go deeper. Let's crack open a proton and see what's actually inside.
Get this, protons and neutrons, they aren't fundamental particles at all. Turns out they're made of something even smaller called quarks. It's like a little trio in there. A proton is made of 2 up quarks and 1 down quark, and a neutron, it's just 1 up quark and 2 down quarks. That's it. It's like a Lego recipe for the heart of almost all matter. Absolutely incredible.
So in a weird way, this actually makes things simpler. All the matter you see around you, everything you can touch, boils down to just 2 basic families. You've got the quarks, they build the protons and neutrons, and then you have the leptons, and that family includes the electron. And the electron, as far as we can tell today, is a true fundamental particle. You can't break it down any further.
Now, physicists have taken all of these incredible discoveries and organized them into this one beautiful, elegant chart. It's called the Standard Model. And you can basically think of it as the complete ingredient list for our entire universe.
And here it is. This is pretty much the crowning achievement of modern physics. Over here, you've got your matter particles, the quarks and the leptons. Now, you'll see there are a bunch more than just the ones we've been talking about. That's because the up quark, the down quark, and the electron are just the stable ones that make up all the normal matter. The others are like their heavier, more exotic cousins that don't stick around for long.
Then over on this side, you have the bosons. These are the force carriers. The photon, for example, carries the electromagnetic force. That's light. And the gluon? Well, it literally glues the quarks together inside protons and neutrons. It's so strong you can never, ever find a quark all by itself.
Okay, so now that we have this recipe book for the universe, let's circle all the way back to that first crazy idea. What about all that empty space?
Just look at that number. Seriously, 99.999999%. That is how much of an atom is pure empty space. All that stuff we just spent all this time talking about, the quarks, the electrons, the whole shebang, it's just a tiny, tiny, almost non-existent speck in the middle of a whole lot of nothing.
This analogy just nails it. Imagine a giant football stadium. Okay, now right in the middle, on the 50-yard line, you place one single grain of sand. That's your nucleus. And the electrons, they're like a few motes of dust floating way, way up in the nosebleed seats. Everything else, the entire rest of the stadium, is empty space. So why doesn't your hand go right through your desk? It's just forces. The electron cloud in your hand is repelling the electron cloud in the desk. What you feel as solid is just an illusion created by force fields.
So, the next time you look around at anything, remember what you're actually seeing. It's not solid stuff. It's this beautiful, ghostly dance of quarks and leptons interacting with each other across this vast, unbelievable emptiness. Everything we see, everything we feel, is just the result of a hidden, subatomic ballet. And that leaves you with a pretty wild final thought, doesn't it? If that's what the world is, what does that make you?